Yeah, warm greetings to everyone. Today I am going to present a topic on wearable rehabilitation sensors. This topic belongs to the field of rehabilitation engineering, which focuses on developing advanced technologies to improve the recovery and the quality of life of patients with disabilities or injuries. Wearable rehabilitation sensors are smart electronic devices that can be worn on the body to continuously monitor movements, muscle activity, posture, and other physiological signals. These sensors help doctors and physiotherapists evaluate patient recovery more accurately and efficiently. In this presentation, I will explain the need for wearable rehabilitation sensors, their working principle, types, applications, advantages and limitations, also future developments. First, let us understand what wearable rehabilitation sensors are. Wearable rehabilitation sensors are electronic devices worn on different parts of the body, such as the hand, leg, chest. These sensors continuously monitor physical activities and physiological parameters during rehabilitation therapy. They are widely used in physiotherapy, sports medicine, elderly care, and neurological rehabilitation. These sensors can measure body movement, muscle activity, joint angles, pressure, heart rate, and posture. The collected information is transmitted to healthcare professionals for analysis. The importance of wearable rehabilitation sensors includes continuous patient monitoring, accurate rehabilitation assessment, remote healthcare support, improved patient recovery. Compared to traditional rehabilitation methods, wearable sensors provide real-time data and better treatment evaluation. Need for wearable sensors. Now let us discuss why wearable rehabilitation sensors are needed. Traditional rehabilitation methods mainly depend on manual observation by doctors and physiotherapists. This approach has several limitations. First, manual monitoring may not provide highly accurate measurements. Second, rehabilitation assessment becomes time consuming because therapists must continuously observe patients. Another limitation is limited patient tracking. Doctors cannot continuously monitor patients outside the hospitals. Home rehabilitation is also difficult because patients may not perform exercise correctly without supervision. To overcome these problems, wearable sensors are introduced. Wearable rehabilitation sensors provide real-time monitoring, continuous data collection, better movement analysis, remote rehabilitation support, improved therapy efficiency. These sensors help healthcare professionals track patients' progress more effectively and improve rehabilitation outcomes. Now let us understand the working principle of wearable rehabilitation sensors. The first step is sensor attachment. The wearable sensor is attached to the patient's body at the required locations, such as the wrist, arm, leg, or chest. Next, the sensors detects body movement or physiological signals such as muscle activity or heart rate. These electrical signals are processed using a microcontroller or software system. Finally, the processed data is displayed on a computer, smartphone, or monitoring device for doctors and therapists to analyze. The main components of wearable rehabilitation systems are sensors, microcontrollers, wireless communication module, battery, monitoring software. Wireless communication technologies such as Bluetooth and Wi-Fi are commonly used for transmitting data. This system enables continuous and real-time rehabilitation monitoring. So different types of wearable sensors are used in rehabilitation engineering. The first type is the accelerometer sensor. It measures body movement, acceleration, and motion patterns. So the second type is the gyroscope sensor. It detects orientation and rotational movement. The third type is the EMG sensor. EMG stands for electromyography. It measures electrical activity produced by muscles and is widely used in muscle rehabilitation. Pressure sensors are used to measure force and pressure distribution, especially during walking analysis. Next, flex sensors detects bending movements and are commonly used in rehabilitation gloves and finger movement tracking. Heart rate sensors monitors cardiovascular activity during therapy sessions. These sensors are mainly classified into motion sensor, muscle activity sensor, physiological monitoring sensors. By combining multiple sensors, doctors can obtain detailed information about patient recovery. So, wearable rehabilitation sensors have many important applications in healthcare. One major application is stroke rehabilitation. These sensors help monitor arm and leg movement recovery after stroke. Another application is gait analysis. Gait analysis means studying the walking pattern of patients. Sensors help detect balance problem and movement abnormalities. In sports injury recovery, wearable sensors monitor muscle performance and rehabilitation progress of athletes. They are also useful for elderly patient monitoring to reduce fall risk and improve mobility. In Parkinson's disease, rehabilitation sensors help track tremors and movement disorders. After surgeries such as knee replacement or spinal surgery, wearable sensors help monitor patients' recovery. Other healthcare applications includes home physiotherapy, telerehabilitation, fitness monitoring. Now let us compare traditional rehabilitation systems with wearable sensor-based rehabilitation. In traditional rehabilitation, monitoring is mainly manual. In wearable systems, monitoring becomes automatic and continuous. The accuracy of traditional method is moderate, while wearable sensor provide higher accuracy. Traditional rehabilitation allows only limited collection, but wearable systems continuously collect patient data. Remote monitoring is generally not possible in traditional methods. However, wearable sensors enable telerehabilitation and home monitoring. In terms of cost efficiency, wearable systems reduce repeated hospital visits and improve treatment efficiency. Patient feedback in traditional system may be delayed, whereas wearable system provide real-time feedback. Therefore, wearable rehabilitation systems offer significant advantages in modern healthcare. So next, let us discuss the advantage of wearable rehabilitation sensors. The biggest advantage is real-time monitoring. Doctors can continuously monitor patient condition and rehabilitation progress. These devices are portable and lightweight, making them comfortable for daily use. Wearable sensors improve patients' engagement because patients can monitor their own progress. They provide accurate movement tracking, helping therapists make better treatment decisions. Remote healthcare support is another important advantage, especially for patients living in rural areas. The data collected by wearable sensors also help in faster recovery analysis. For doctors and physiotherapists, wearable systems provide continuous patient information, better treatment planning, reduced hospital visits, improved rehabilitation management. Overall, wearable rehabilitation sensors improve both patient care and healthcare efficiency. So, even though wearable rehabilitation sensors have many advantages, they also have some limitations. One limitation is sensor calibration issues. Improper calibration can affect measurement accuracy. Better limitations are another challenges because wearable devices require regular charging. The initial cost of advanced wearable systems may be high. Data privacy and security are also important concerns because patient information is transmitted wirelessly. Motion artifacts can affect signal quality during body movement. Another limitation is the need for technical expertise to operate and maintain the system. Additional challenges includes long-term durability issues, wireless connectivity problems, signal interference and accuracy problems. Researchers are continuously working to overcome these limitations. Now let us see Some recent innovations in wearable rehabilitation technology. Artificial intelligence is being integrated into rehabilitation systems for intelligent patient monitoring and movement prediction. IoT enabled wearable systems allow doctors to monitor patients remotely through internet connected devices. Smart rehabilitation gloves are being developed for hand and finger rehabilitation therapy. Flexible electronic sensors are another important innovations. Wireless body sensor networks allow multiple sensors to work together simultaneously. Cloud-based rehabilitation analysis enables patient data storage and remote access. These innovations are making rehabilitation systems smarter and more efficient. Next, future scope of wearable rehabilitation sensors is very promising. In the future, fully AI-assisted rehabilitation systems may automatically analyze patient condition and provide therapy suggestions. Smart textile sensors may be integrated directly into cloths for comfortable health monitoring. Researchers are also developing implantable rehabilitation sensors for continuous internal monitoring. 5G technology will improve remote monitoring with faster and more reliable communication. Advanced robotic rehabilitation systems combined with wearable sensors may provide highly accurate therapy support. Future benefits include personalized rehabilitation program, better healthcare accessibility, reduced rehabilitation cost, improved patient independence. Thus, wearable rehabilitation technology will play a major role in future digital healthcare systems. To conclude, wearable rehabilitation sensors are transforming modern healthcare and rehabilitation engineering. These systems provide real-time monitoring, accurate rehabilitation assessment, remote patient support, improved recovery outcomes. Compared to traditional rehabilitation methods, wearable sensors offer better efficiency, continuous monitoring, and improved patient care. With future advancements such as artificial intelligence, IoT, and smart wearable technology, rehabilitation systems will become even more advanced and accessible. Overall, wearable rehabilitation sensors are improving the quality of life of patients and supporting the future development of smart healthcare system. I hope you all are understand the concept. Thank you very much for listening the video. Thank you.